Hi everyone, and welcome back to the channel. So in what I hope to be the last video of where I'm mostly talking, I want to cover briefly the concept of object-oriented programming, and to do that, to help us kind of learn a little bit about what that is. I want to reference a blog post from a friend of mine. His name is Kevin Smith. He's a developer in Nashville, and he's a lead. Like he's in charge of a team there, and so it's this blog post right here, and I think I have it pulled up. Yeah. Okay. So he describes object-oriented programming. Okay. So let me back up just a second. So he actually does this as well. So he starts talking about procedural programming. Okay, so if we think about programming, right, we think of it, you can think of it as a means of manipulating data, right? And we're trying to automate that manipulation, right? So we're writing logic that deals with data and that processes data. So essentially we're writing logic that will manipulate data. Okay, now what we want to do in terms of object-oriented programming, right? So you could think of that, you could think of like solely writing logic to manipulate data as like procedural programming. You're going to write logic or procedures to process some sort, to do some sort of thing. Okay, now, and we're going to do that when we create objects, right? But we're going to do it hopefully once. So if you watch the last video, I talked about, I touched on a concept or a principle known as DRY, which is short for don't repeat yourself. So the idea, so what we want to do, which is the whole reason that we're trying to write programs anyway, is to automate something that's a manual process, right? So when you're writing a program, you don't want to manually write the same logic over and over, right? So you want to write it in a way, and we talked about this already, but that's reusable, okay? And so that is the the core thing of object-oriented, the mindset of object-oriented programming is that you want to write and develop your code in terms of, and you want to think about it in terms of the manipulation of objects as opposed to the manipulation of data. Okay, so what Kevin does is he provides an example that I think is really good. In that, okay, so well, I'll discuss the example quickly. He says when you go to a restaurant, they show you a menu of choices. You tell the waiter what you want. They bring it to you, and they bring it to you. And so what you don't do is you don't go to the kitchen. You don't check the inventory. You don't get the things that are needed to prepare the meal, and you definitely don't go and tell the chef how to prepare it. Okay, you leave all of that responsibility to the restaurant. Okay, so they advertise a delicious dinner, and you trust that they can handle it. Okay, so that is essentially what we want to do, or what we want to emulate when we are writing code. We want to within the context of object-oriented programming. That is essentially what we want to do. We want to think of things and use things like objects, right? Just like we do in the real world. So in object-oriented programming, you can think of it as a way of building software that encapsulates the responsibilities of the system in a community of collaborating objects. Okay, so thinking about the restaurant example, you have a waiter, right? So you could, if you were writing a program that emulated an experience, the experience of going to a restaurant, you would have a waiter object or waiter class, and then that waiter would have properties, right? So they would have a name, they would have maybe like years of experience, they would have shift, like which shifts they work, they would have and then they would have behaviors, right? They would have take order, input order, carry food, that sort of thing. Like they would have those sorts of behaviors. And then if you were writing, if you wanted to create new waiter objects, you wouldn't want to have to write the logic of how they carry the food every single time, right? Like, so you would create that as a behavior, or what we talk about, what we call them is our methods, and then you would, every time you need a waiter to do that, you would just call that method as opposed to rewriting that logic, right? So he goes on to talk about that, and then he says an object consists of information, which are the properties of the object, and behaviors, or the methods of the object that operate on the object's information, okay? And these work together to fulfill the object's role in the system, okay? So if you want to read through his whole blog post, here's the link. He has a great blog. It's kevinsmith.io. And he's I can't remember if I've said this before, but he's more heavily involved in PHP programming. But I believe, and if you're not familiar with PHP, it's a server-side language for the most part, and but I believe it's C-based, so it's it's going to be similar. If you try to read that blog post, he has some code there. You could if you understand like C or C# or something like that, you could probably follow along with it. But anyway. So back to object-oriented programming. So we want to think of it as the manipulation of objects as opposed to the manipulation of data. Okay, so we want to think of it from a higher level. And so we don't want to get into the nitty-gritty of the lower level of the logic. Okay, so the first part of that, or concept of that, is abstraction. So that's thinking about things from a higher level. So we want to understand what the object is and what it does without needing to know how it does it. So exactly that. We don't want to worry about the nitty-gritty, right? We don't want to get into the weeds of what these objects are doing and how they do it. We just want to understand what they do and how to use it, right? And so the next thing is inheritance, okay? So I have an example down here. Well, I'll describe it first. So it allows an object to possess the same properties and behaviors of another object, okay? And it allows it to possess those properties without having to explicitly define them within that new object, okay? So as an example, I've created two, and here OOP, that's short for object-oriented programming. So if you see OOP or OOPS or something like that, then that might be what they're referring to. So I've created these two objects, right? So if you're thinking about creating an object or a class, right? So we can think of this as a person object, right? So what are some of the properties or the information that a person would have? They would have a first name, they would have a last name, they would probably have an address, they would have an age, maybe they would have they would have a public date, time, birth date. Right? So we could give a set, or we could do like a well, I guess you would need to be able to assign that, but yeah, so we would have this person, right? Well, let's say, you have a business and you have an employee, right? Well, you don't want to have to come in and create your employee class and say, well, we know they have a name, right? It would be a string, first name, get, set, etc. Like we wouldn't want to have to go in and like say all those things. And you could just do this, really. You could just copy and paste, right? So now an employee has a first name, a last name, an address, etc. Right? Well, we don't want to have to do that, right? We don't want to repeat ourselves, like, we don't want to keep rehashing out like the logic and stuff. Okay, so the second, this, inheritance, what that is we can inherit from person. Okay, so now you can see that this gives us a green squiggly. It's basically telling us that we don't need it because it already exists. Okay, so you might say, well, how do you know that? Well, if we come up here and we create a person 1 equals new person. Okay, then we can say person 1 dot age, or first name, whatever. Well, actually, what we want to do to prove that we have, let's see, we want to create an employee. Okay, so we got a new employee, and this is because we're not giving it any information. That's why it's doing that. So let's say employee 1 dot age, right, or first name. Well, we didn't give it that property. Okay, so that's the beauty of inheritance. Okay, now eventually what you'll hear about and what we'll talk about are interfaces. Interfaces are contracts. So you could, if you had like an iPerson class or an iPerson interface, then you would just be, well, we won't get into that. That doesn't matter right now. But you'll have inheritance, and then you'll inherit from an object, but then you could also inherit from like a bunch of other interfaces, which are just contracts. They just say this object inherits from this. It needs certain properties or methods or whatever. Okay, so anyway, so we have access to all these different things. We have access to department, obviously, because we explicitly said that it has a property called named department. Okay. But we also have the same properties of the person because we inherit from person. Okay, so that is inheritance. And then the next thing is encapsulation. Okay, so encapsulation, in short, it protects the inner workings of an object from the outside world. Okay, so we don't need, so like we've just created this employee, right? And if you look down at this employee class, I gave it an object that's able to drink. Okay, you don't really want the person who's using this class to be able to determine themselves, to write their own logic as to whether or not they're able to drink, right? We have a rule that says whether it should be or not. In the US, you've got to be 21, right? So you don't, if you have someone who is creating this employee class and for whatever reason they have this property of they're able to drink, then you don't want them to be able to determine that on their own, right? So you want to encapsulate that logic within the class itself so that when you create the employee, you give it an age, and then it determines on its own whether or not that person is able to drink, as opposed to allowing the person who creates the employee object to determine that. Okay, so that's encapsulation. And you can see here so what these are these are constructors. Okay, and these are different ways that we can generate this employee. So we could create an employee by giving it a first name, a last name, and an age. Okay, and then we would check if they're over 21, right? So in other words, the difference being that, so we can see that if we look at the person, right? Well, we've not given it a constructor where it will do it for us. So in other words, in order to create this person, we have to actually, we have to say first name equals Joe. Okay, and then let's just copy these. So last name equals Schmo. Okay, and then age, we'll say, is 42. I don't know. For whatever reason, Joe's in his 40s. Okay, and that's giving us a mark here because we gave it an int, right? So, which is fine. We could, you might, if you're dealing with a database, maybe it's stored as a string, so maybe, you want to actually give it a string, but maybe you want to be able to perform like math using it, right? And you don't want to have to convert it to an int or whatever. Those are just things you have to think about when you're saving things to a database or something like that. So anyway, it's age 42, and then we'll just get rid of that. Right, we don't need to give them an address at this point. So at this point, strings can be null or empty. So we don't, you don't have to give it that. So and if you've watched the other videos, we've talked about putting a question mark, and so you could, if you had a double, an int, right? If you want to make it, which actually, yeah. I don't actually know if you can do that, but let's say we did a double instead. So we could make it nullable. Well, just for a second. Well, there we go. Yeah, so we could do it. So we can't do that with string because strings are already that way. And then if we did int, yeah, you can have a nullable int, right? So anyway, got sidetracked there for a second, or sidetracked. So let's say we want to create this employee, right? And it's given us, so we have these constructors, and so we don't really want, the nice thing about constructors is that we don't have to force the person creating the object to do all the thing, to set all these values for us, especially when we're talking about able to drink. We don't want to force them to have to calculate that or whatever. We want to create these constructors where we give it information and then it takes care of the creating the object for us and assigning the values and all that. So that's that's a form of encapsulating the logic, the nitty-gritty portions of the object within the object itself. Okay, and then the last thing is polymorphism, and really it's just as simple as the definition. It just says one name, many forms. So things that are named the same but but have different behaviors. So an object can behave differently given different circumstances or uses, or different inputs, right? So think of I saw a really good example of being your phone, right? Or like a smartphone. It's the same object, but it has multiple behaviors, right? You can use it as a camera, you can use it as a still camera or a video camera. You can use it to call people, you can use it to text people, you can use it to play games. There's the same, one thing has many forms or many behaviors, right? So same thing with this employee constructor. We've got the same name, right? But there's, based on the different inputs, it does different things. Okay, so in this case, there's a department provided, but in this case, we give it, instead of, because it pulls from a person, we can, it's actually not because we give it, a person has properties that we would use, right? So instead of having to give it a name and all that stuff, maybe you already have a person object, so you want to give it a person object and then just give it its department, right? So and then you just assign the first name to the person's first name, and then the person's last name, the person's age, and department. And then you've set the age, so now you can just say, well, able to drink is this property, right? And you can see another form, another example of polymorphism is that we have these two methods. One is private, where it doesn't take anything, there's no parameters here. and it just returns whether or not the age is greater than or equal to 21, right? So if, in our example up here, person 1, Joe Schmo, he's 42, so he would, if you ran this method, that it would return true, right? So that person is able to drink. And so you can see we've named it exactly the same thing, but we have different parameters, right? Now what you can't do is have two of the same thing. Whoops, that's just silly. Can't type. Okay, so you can see that now this is gives us it's complaining, and it says that script.employee already defines a member called is over 21 with the same parameter types. Okay, so this is just duplicate. This is not necessary, right? So it's complaining about that. So anyway, so that's polymorphism. So so yeah, I think I know if you're new to programming, and you might be like, well, why are we talking about this? Okay. The reason that I wanted to go the reason that I wanted to cover some of these topics, these like more high level or more complex things, is because these are the things that I wish that I had had the forethought to learn some of these things early on, so that I could have a steeper learning curve. And that's my goal, is to help you to learn how to write good code sooner in your journey, so that you can really start to build projects that are really complex and that really do cool things much quicker. All right, so with that, our next video, I believe we're going to start very simple with a very simple project that will find a PTV, and it will get the prescription dose, and then it will calculate the CI. Okay, and then we're going to develop that into more and more complex examples of that same type of script. Okay, so the first thing that we'll do is we'll write a single file plugin for Eclipse that will just do that, and then we'll talk about the ways that you would, the different circumstances that you would use it. Right, so maybe if you only have one PTV, that's great. You just find the PTV and you calculate it. But maybe you're talking about a frameless, and then you have multiple PTVs or multiple dose levels in the same plan, and that sort of thing. So, and then maybe you want to create a UI, right? So then maybe you want to build a class library or a standalone executable or something like that. And then, so we'll develop that into like a pretty complex script. Another thing that I want to build out is a tool that you can use to uninterpolate structures. That's actually pretty useful from like the perspective of like a physician or residents or something like that. If you're like in a large center where you have like residents that are contouring, and you're a physician and your resident has contoured something and they've interpolated it, and now you want to edit it, but you don't want to have to delete slices manually and then edit, and you definitely don't want to just redraw the whole thing, or maybe you do, I don't know, maybe you need to, but anyway, things like that. But we're going to start with the conformity checks and plan checks and stuff like that. And we'll go from there. So if you have any ideas or any comments or anything, be sure to let me know. And then if you want to follow along, then be sure to like and subscribe so that you'll be notified when new videos come out. And until then, I hope you have a great day and happy coding.